Yep, it's a Xerox Work Center 7225.
I guess we could slowly start.
Yeah, I was just going to say, welcome to the IAB open meeting. Miria is also, Miria and I are, here to give you the grand tour of all the recent activities in the IAB. She's the chair, and the rest of us, have to do what she says. No, just kidding. Welcome to the IAB open meeting. With that, we have the usual things. We have, obviously this is, the note well. If it's Thursday and you haven't seen the note well, good job, or you're enjoying your summer vacation well. Definitely, that. So what is IAB Open? The IAB, it's an IAB organized session focusing on all the technical and architectural topics. It's really trying to give everyone visibility into the IAB work, collect feedback, and such. Here's a list of the mailing lists, where you could go and reach out to the IAB. We have a number of different programs and liaison activities that we're responsible for coordinating. So, agenda, welcome status update. We're doing that. We'll have updates on liaison management. Wes will present for that. The EDM program, Tommy's going to spend some time talking on that. Some considerations on applications, and then some open mic time after Yari talks about his little piece.
I didn't update the slide. I guess it's Tommy on liaison management as well, but it doesn't matter. I think they're both able to report back.
Okay. Let's see, and then, yeah, do you want to talk to, you said you're awake. You want to talk about document updates, or?
Sure. So good news is we published the report from the last workshop that we held in November, which was the COVID-19 impact. So that's out there. It has an RC number, and we're happy if you read it and also provide still feedback, even so it's published. Then we have one document that is approved for publication, but you might still want to have a look at it. And then I really wanted to draw your attention at there are a few more documents that are somehow on the horizon for the IAB, but the one which is called Draft IAB Use It or Lose It is the one that is like probably the next one we will look at and evaluate, and that's currently in discussion in the EDA program. And if you want to review it, if you want to comment on it, then it's the right point of time to do it now, but I'm pretty sure Tommy will talk more about it later. And now Jared disappeared. There he's back.
Yeah, I just wanted to turn the light on.
Technical programs, just a very quick update. So what we did in the last couple of months is, or still doing, is that we also review these programs, figure out where they are, what they should be doing, and what they're needing. We did recently review the EDM program, and Tommy will tell you more. And there's a review scheduled for the Model T program in next month. Currently, there are a bunch of documents which are in the scope for this program, but there's not really a lot of active discussion or any document that is really taken up by the program. But we will discuss what to do next year during the review next month. And then we wanted to also point your attention at something new that we're doing on the IAB, which is we now have one of our calls once per month. Our calls focus entirely on technical discussions only. So usually those calls will have only one topic scheduled, and we have like a full hour to discuss it. And you can see here some of the topics that we discussed over the last couple of months. So this is a mixture of things that is brought up by the IAB members, by the community, and also since we have these kind of invited talks where we have external experts into a topic that we find interesting, Or recently, we also had some people from ISAB providing us some of the more legal and political background for a topic that we discussed on the IAB. And the reason why I'm mentioning this here is because all the IAB calls are open for observers. So you could even join all of the IAB calls, but you can also just look for the interesting ones, which might be one of these technical discussions. The agenda is usually published on our IAB web. There's also a calendar you can subscribe to, so you have it in your calendar and you can see what's going on. And of course, if you miss a meeting, you can also check the minutes. You want to take that one again, Jared, or should I go on?
Yeah. Actually, this one I'm very excited about. This one is the workshop, IAB workshop we've put together. Or a number of people are working on it. I'm very excited for this on measuring the network quality for end users. Really, you can read what the questions are. We're really soliciting people. Submissions are due on Monday. So just in a few more days. For that, and we want to understand things. So if you could please, if you have any data or anything interesting you want to share, any interesting observations, love to. I know I personally would love to hear about this. As somebody who works in CDN, but also runs my own end user network, where I care quite a lot about the user experience there. And so any ways I can use to measure that. Is going to be, I think super interesting for the community. And then, let me go back and we'll leave this open mic for the end. And let me hit the right button to share. All right. I didn't double check if this is in the right order for this. Let me see. EDM.
Okay. I think we may have been good. We're supposed to do the liaison one first, but it doesn't matter because I'll do both of them. So we can talk about the EDM program first. All right. So I'll just give a brief update on this technical program that we have on evolvability, deployability, and maintainability. If you are interested in joining us in discussions for this topic, you can join the mailing list, edm@iab.org. David Skenazy and myself are co-leading that currently. Next slide, please. So just for administrative stuff, we've had, I think, 3 or 4 calls at this point. We have our next one coming up next week on Wednesday, August 4th. So if if you've had your full IETF week and you just want more and you miss everyone already, feel free to join us. And I think we'll actually be having another call probably in September, October before the next IETF as well, since some people won't be able to make it to this one. So don't worry too much about it. We will be talking about I will be talking more about the user lose it draft, which, as Maria mentioned earlier, we are trying to get out the door and published very soon. And we also have some new topics that we're talking about. Charles Eckel proposed some work on how to find code implementations. And that's one topic that will probably also bleed over into the next call. And then we'll also want to talk more about coordination mechanisms between implementations, which is one of the topics that kind of comes out of user lose it. All right, next slide now. All right, so just to give, I wanted to give a brief kind of overview of this document since we're trying to get it to progress. So if you are interested in reading it, you can kind of get an idea of what is in the document. Currently, we are on the 01 version of the IAB document. It had a lot of earlier individual draft document versions. And we'd like to get this ready to publish soon before the next IETF. And so essentially we are soliciting reviews and thoughts. We've already asked the EDM list for this sometime after the call. Once we've merged in everything and had a good discussion, we'll ask for wider community review. Next slide. All right, so just briefly going to cover the different things that are in the document. Martin Thompson is the primary author on it, so he can, of course, comment more, but here's my attempt at summarizing some of the points in here in case people are interested and have questions now. So first of all, it talks about what are the things that limit protocol evolution. Talks about the fact that you can have implementation bugs around extension points that make it hard to use extensions in the future. And I think the big point here is really that a lot of previous design around how you can thought around how you can design a protocol well to guarantee extensibility isn't enough, because things not being actively used and ossifying, even if they're designed perfectly, can still lead to loss of extensibility. And this is particularly hard when you have middle bosses. Martin.
Hey, Tommy, so we have Martin in the queue. Do you want to?
Yeah, sure. He can comment on his document.
I think probably the only other thing to add here is that a lot of this depends on the fact that the participants in the protocol deliberately decide to block extensibility, but they just do it by accident, by virtue of the bugs or not thinking about it or what have you. There's recent changes in the draft to sort of try to capture that one. That's not in the draft that you will see, because that came out of discussion after the last revision went in. But we've clearly identified a threat model now and tried to break out the case where you have protocols and participants in protocols that deliberately block certain aspects of extensibility. And that's not really in scope for this work.
Yes, exactly. Thank you for clarifying that. All right, next slide. There we go. Yeah, so essentially once it establishes that background, it takes a look quickly at what are the things that promote extensibility. It looks at some of the protocols that have good extensibility properties and notes that those are protocols that often use these extension points a lot. And that's in two ways, right? It's both in defining new extensions or new values for these extension points, as well as actually using them in practice. And kind of beyond just really using these extension mechanisms a lot, it's really best when the functionality of the protocol altogether has a strong dependency on that extension point, such that if something happens to it or you have a bug in that extension point, everything falls over and you notice it very quickly. And it's also noted that there are some examples of protocols that had kind of lost their ability to use their extensions, and then they regained them by active use. So that leads on to the next slide. Essentially, the document ends with some of observations and recommendations, primarily that active use is the biggest thing to guarantee extensibility, highlights that version negotiation is an interesting special case, and that techniques like grease or greasing a protocol is a way to get some of the benefits, but not all of them, by falsifying active use. So if you're not actively deploying new features, you can at least get some of the benefits. And then there are a number of things that relate to improving how active use can maintain extensibility, such as using cryptography and encryption, having a relatively limited set of extension points so that they get used a lot, defining invariants, and monitoring brokenness with feedback. And I think that's it for these slides. Can you check one more? Or is this it?
Yeah, that's the last slide.
Cool. Yeah. So that's a summary of the things we are talking about in this document and talking about in the program. So I think we do have some time in case anyone has other comments or questions about the work. Jeffrey.
A quick comment. This is coming out of Yang work, specifically the BHP Yang work. One of the interesting headaches that we sort of see is that extensibility is hard to prove until you've actually tried to do the first version of that extension. So as an example, an awful lot of our stuff is basically just barely v1.0 for a lot of the documents. A lot of the maintenance that needs to be done is in many cases simple, but BGP being a very flexible protocol with a lot of extensions, we've had to do a lot of what I like to call inner work to make sure that can you actually do the next thing for this extension based on what BGP would need to do for the Yang model and its extensions. So one thing I'd encourage for the document that you're working on is try to find a way to prove out the n+1 case.
Cool. Thank you for that example. All right. Bob?
Thank you. Yeah, we've had quite a lot of experience with in IPv6 with extension headers, hop-by-hop headers, destination headers, and it's not been a wild success, I guess I could say. I think the particular problem is, in hop-by-hop headers, in transit routers, but I think the worst problem is middle boxes that filter or decide they really want to look at the whole packet. And we are trying to fix some of that, but it's a really hard problem. And so I'm very supportive of this work, but it's, in the real world, it's going to be challenging.
Yes.
Things tend to get very static very quickly.
Yeah. I wish there was kind of a silver bullet that could be offered, but I think a lot of this is just writing down, things that are hard, and I think IPv6 has a lot of challenges given its exposure to middle boxes like that.
Yes, I mean, so it's also a good place to learn about what's really happened, I think.
Yeah. Thank you.
Thank you.
Elliot?
Afternoon. Tommy, I did have a look at this draft when it initially came out, and I just reviewed it again. One of the examples you give is IPv4 and Class E addressing as being wasted space. Two comments I want to make. The first is there is still an open question as to whether that's really true. As the person who co-authored reuse of 240, I know we dropped that, but I know that there are people who really think it's okay to use that address space and have tested against it for now, and just repurposing it for unicast. The second point I want to make about that example is if we didn't have the reserve space, I'm not sure we would have known what to do about multicast, quite frankly, which wasn't invented at the time of RFC 791. So I'm not sure that's the best example, which leads me to my general point. I think what you guys have done in the IAB in this document is probably far more applicable at the upper layers than it is at the lower layers. And in that, for one thing, it's hard to know what's in use where, and for another, the agreements, the nature of the agreements are quite different between the upper layers and the lower layers. And I think it's probably worth developing that concept a little bit in your work. Thanks.
Thank you. All right, Tobias.
No, I think actually it was good getting back to that example with the multicast, because I just need to write a bis on that 30-year-old stuff where exactly these extension point things and the things that went wrong, right, which I wrote you back in my review, right, are coming into play. So I think I'm not sure, the layer difference between layer 3 and 4 work and your lovely, much easier, much more agile, I'm just jealous, right? So land of the applications is probably really that the unit of time which is in the scope of use it may just be orders of magnitudes larger, right? So I mean, if in our case we start using extension points every 5 years, we're happy, that was fast, and in your case, an application that might be an eternity, right? The other part then is really just the two-party versus n-party thing, and I think what I heard in before just the typical TCP where just two parties are talking with each other versus when you actually want to explicitly have desirable middle boxes like the proxies, as you said, right? And IP obviously is the desirable middle boxes because you have n forwarders in the path. And I think, yeah, definitely what I heard in before here in the comment, maybe putting the undesirable middle boxes out of scope, because right now it's a little bit leaking out into that, because that's a huge other area of itself. Maybe at that point in time when we take those out of scope, then we can still figure out how to discuss it's a simple peer-to-peer communication or it's a multi-party communication. And that might be able to capture both of the application and the network layer. We'll see. Thank you.
And
I'm sorry, I'm just going to comment real quick. I'm going to cut the cue at Bob, and then we can come back to it if there's time at the end.
Yeah, makes sense. In our previous calls, we did talk some about the nature of the problem and what use means is very different at different layers. So I think that's something that we can continue to discuss and capture better in the document. Martin?
Comment there about the upper layers thing. The introduction of the draft actually deliberately addresses the point and says, and I quote, the experience that informs this document is predominantly at higher layers of the network stack. And so I think we've been very clear about our biases here in terms of what the learnings are. We do have some examples at lower layers of the stack. They are not necessarily very good. And to Bob's earlier point, the IP extension header thing is an ongoing discussion that I don't think we can draw any real conclusions from at this point. And I sort of mentioned the existence of the problem, but haven't really tried to point at any one solution for that sort of thing. So I think we are getting there, but I'm not really enthusiastic about trying to formalize the difference. One of the things that came up in earlier discussions about this, and I think Tolas mentioned this as well, was that the cadence at which updates occur may determine the shape of the response that you have, but that doesn't necessarily mean that the fundamentals are necessarily different. So you update on a 5-year cycle, fine. Then you update on a 5-year cycle, and some of the things that you might need to do on the interim might be a little different, but the fundamentals are about the same.
All right, Bob, you have the last word.
Yeah, so I think a way of characterizing this is it's much easier to update or extend things when you're only having to change 2 boxes, 2 hosts, because I think Quick is a very good example of this. The way Google and others have rolled this out, you do some queries and you see it supports the new one and you can use it. It's much harder when you're having to change everything along the path needs to do it. And so I think that's maybe a good character way. It's not so much the layering, I think, it's just how many things have to change in order to get any advantage of it. Personally, I've worked on 2 protocols that I've been very happy with, VERP and IPv6. With VERP, all you need to get 2 boxes to do it, and it did something useful. For IPv6, you had to do everything you had to do it globally. And so, there's different kinds of scaling here that you can think about. Thank you.
All right, thank you everyone for the input. If you want to talk about this more, come to the EDM call next week. All right, moving on to our next topic. Wes did a lot of the work creating these slides. I'm going to be giving them on his behalf. So we want to talk a little bit to this group about liaisons and specifically what we are doing in the new liaison coordinator role. So back in March is when we established this liaison coordinator role as we closed down the previous liaison program. And this is currently filled by myself and Wes, and you can reach us at liaisoncoordination@iab.org. And this is a role that we expect to have continued and have people rotate in and out of, and have essentially at least two people who are giving a lot of focus to what the liaisons are doing, and specifically making sure that we have a good set of communications with our liaison managers. And so our first task that we've been going through is talking to all of the liaison managers that are currently appointed in 30-minute one-on-one sessions, essentially, to understand what the current status is and what the needs are. Next slide. So this is a just kind of preview of the different things that we talk to the liaison managers about. They're generally pretty open-ended conversations, but we wanted to understand how much time people were spending, how much prior knowledge they needed to fill their role, and specifically what type of communication was going on from their organization and from their liaisonship to the IAB, and what the IAB was giving its input back to them to highlight where the places that things are working well and where the places where we're not doing as much as we should for a given liaison. Next slide. So we haven't kind of formally compiled all of the information. I think this is going to be a discussion that the IAB will have ongoing for some time after this, but some initial observations we can make at this point. There are a lot of the liaison roles that we found that are essentially no-ops. Maybe they're a role that is required to be filled because there's some charter reason in a given organization that needs a certain role to have someone sitting in it. But then there are other roles, particularly the appointed positions that are not traditional liaisons, but something that is still appointed in that general bucket of people spending quite a lot of their time on these roles. So there's a huge range of involvement and requirements for these. And a lot of them also have different cadences depending on whatever organization that they're liaising with. Sometimes it's a once a year thing, twice a year thing, etc. And there's also a pretty big variety in what type of backgrounds that you need to fill the role. Some of them are quite technical, but others are really about understanding the organization and essentially the social structure there and how to work within it. So these are the type of things that we want to make sure are documented well, so that as we need to fill liaison roles going forward, we know who are the right people to fill those roles. Next slide, please. Yeah, so the next steps here, the main concrete thing is that we want to start establishing more official communication frequency from liaisons to the IAB. This doesn't necessarily need to be a lot of things being said, but just a status update on a regular cadence so we know what is active and what isn't. So we can understand from the managers what they're working on some regular cadence. And we'd also like to have more regular meetings between the coordinators and the liaison managers, as well as opportunities for the liaison managers to present their status to the whole IAB at IAB meetings. This is something that hasn't happened for quite a while. And then overall, just our goals as we're thinking about this are to improve the communication that we have to the liaison managers, improve the amount of attention and focus that we're giving to liaison activities to make sure that if there are things that we should be doing more proactively, we can understand what those are, support the liaison managers more in general, and also to have a clearer point of contact when people in the community have questions about what they should do for a given liaison. I think that's it here. So do we have any questions or comments on the liaison work we're doing? All right, sounds like that.
Well,
Thank
all right. Well, thanks, Tommy. And I'm ready, Yari. Just tell me when to click.
Yeah. So this is a topic that some of us current and ex-IABers have been talking about, application network collaboration and path signals and how to do them properly. And the name of the draft actually is mistakenly set here as draft ARCO path signal something, but it's should have IAB there somewhere. Draft ARCO IAB path and so forth. Okay, next slide. So what are path signals? These are signals that that applications or endpoints send to or receive from on-path elements, such as routers. And of course, in the past, path signals have been often implicit, for instance, derived from the in the clear information that exists in packets, such as TCP options and other data that just happens to be readable, and entities have been reading this piece of data. And as has been discussed many times before, this results in some negative effects. Ossification, because you can't change things that people somewhere depend on. It's also a systemic incentive against building more secure protocols, because that would disable some of these functions that people are doing, which, you know, we can go against that, but it would be nicer if we didn't have that incentive built into the system today. Also, you might be basing behavior in the network on information that could be incomplete or wrong, primarily because it wasn't really designed to be read in the network. And also, you basically, if you have this kind of setup, then you create an expectation that network elements can see rich data about flows passing through them, and that's not the reality that we're living now or will be living in. So, not the right signal to send or expectations to have. Next slide, please. So that was the past. Of course, now we have some good news with increased use of encryption. A lot of this has changed for the better. We won't be doing some of those things anymore. Of course, at the same time, kind of radically cut down on this kind of interaction, and perhaps there's some need for some of those interactions to actually happen. So maybe we're in a situation where sort of cutting away almost all of this signaling, and now we have to build some of it back, the parts that actually make sense and have positive incentives for all the parties to actually engage in. And also, the other part of the good news is that given this encrypted situation, it's now also an opportunity for us to redesign whatever things that we actually need. We can redesign them to do things properly, or be explicit, for instance, and be secure. We do have some existing guidance from various documents. I'll mention TED's RC 8558, which basically recommends building for confidential operation by default, and then using these explicitly designed mechanisms for sharing data for the few cases where you actually need to share some data. Also, there's a really good document in PunRG about what not to do, basically going through a lot of examples from the past, what has been done, providing some guidelines and documentation of failures and some reasons for those failures. So do read these documents. Next slide, please. Okay, so our document then goes through a couple of different things and tries to make some recommendations at a sort of abstract high level. The first one is this intentional distribution, basically following what RC 8558 said. So don't do things by accident. Do things if you actually intend to provide some information. Some bad examples here, things that one should not be doing, like a middle box should not be reading TCP options and transport protocol headers. Maybe a better example could be something like ECN bits or spin bits, where you actually designed a particular mechanism to convey a very limited set of information on purpose for different parties. The other principles relate to minimality. So first, both a minimal set of entities. So limit the exchange to those with a need to know. And so one example here is that if you have clear text DNS queries, it's possible that parties on the path will read them and perhaps act on them in some inappropriate ways, or things that make some things not work, for instance. And a better way of doing that would be actually to encrypt the queries so that you only target the particular entity that you want to perform a task. And I know I'm maybe stretching a little bit the definition of path signals in this particular case. Should DNS queries be included in that? Maybe, maybe not. Moving on, so minimum information. Don't provide information that is sort of extra, just the information that is needed for the task. So some bad examples that you could try and do, like if you try to communicate the user's identity or real world identity, or application's exact identity, that's probably bad for a number of reasons. Like obviously don't want to necessarily communicate user's real world identity to like all possible parties on the path, but you might also not want to reveal the application's identity because that might lead to things like blocking particular applications or providing a preferential or negatively preferential treatment to some applications. But you might be doing things like describing that I have these preferences for my traffic, that QoS or some other treatment. And that might be completely okay. Of course, you should have consent of parties. So essentially both sender that is willing to send some information, and obviously in this new explicit encrypted design model, only those who actually want to send something will be doing that. So that's kind of easily handled. But also the recipient and ultimately the user needs to be willing to do things. So some bad examples. Let's take an example of sort of the recipient side. So as an example, we've had lots of discussions in the IETF about various brokers' ability to process hop by hop headers or willingness to process. So that's an example of a thing where somebody, from the endpoints wants to send some information, but the receivers don't actually want to process it because it will significantly impact the ability of those devices to function efficiently for the fast path case. And so the general rule here, at least for the centerpiece, is that the application needs to decide that do we actually want to provide some information. It's good to be able to make that decision. And in some designs, like a quick spin bit, for instance, you have some specific mechanisms for sort of randomly choosing in which times you use some information and which times you don't, in order to make any kind of tracking or detailed analysis impossible, while still making it possible to provide some general measurements. And finally, securing the signals. You need to think about whether the information needs to be protected in somehow. Do the parties need to be authenticated? And there might be different cases here for different situations. So you might have a simple case. You share some simple data, for instance, the ECM bits, and maybe you don't need to encrypt that in any fashion. You may actually want to be able to show that information and be able to modify that information sort of in multiple different entities. And the impacts of changing that isn't all that dramatic anyway. But then you have potentially more sensitive data. Again, my stretched example of DNS queries here, you don't want other parties to learn of particular users' browsing habits or domain names that they are visiting. One note about authentication. So you might have authentication of parties, whether it's this specific nodes or otherwise bigger groups of nodes. And even if you do authentication, it doesn't imply that you actually have full trust into the entities. As an example, you might authenticate the party to do some service where you provide some confidential information, but the party might still leak that confidential information for commercial purposes or by accident or something. Next slide. So those on the previous slide, they were sort of guiding principles that we can sort of clearly enumerate. On this slide, we have a few topics where we believe that some further work is needed, and it's much less clear situation, or some aspects of the previous slide also here, like security. One common topic here is the business arrangements, and sometimes you've had lots of complicated designs. Let's do some QoS design, for instance, and there's a technology side of that, but there's also a business side. So if you start to assume things like, well, we need to be able to pay for a service, and we get paid for doing something. So in those situations, the technology itself is not enough. We actually have to have a business model to back that up, and that's really important. So if whatever you're trying to do requires that, then you do need to think about it. Secure communications with path elements. We talked about this a little bit on the previous slide, but that is of course in the general case fairly hard. So you might have like multiple parties and so on. So there are some challenges in this, of course. You could have potentially various kinds of new ideas about how to do new things with path signals. And one idea that we did talk about a little bit, Ted had been working on something in this space, and maybe he wants to talk about it later on the comments a little bit, but you could perhaps do some throttling of flows related to denial of service attacks, for instance, if we had the necessary path signals for that. Hand waving a little bit here. We could do more protection of information held by various network elements or even by the servers, essentially going beyond communication security. One example here is the various oblivious DNS designs. Confidential computing is another example, could be applied potentially. And also, we in many cases talk about these path signals in terms of, well, can the application tell the network something, or should the application tell the network something? But there's also the other direction. So it could be that the network wants to or can tell something to the application that would be useful in terms of like the transport parameters or congestion control or future expectations of bandwidth and so forth. One example here is that the mobile networks actually know quite a lot about the network capacity and the pipe that's available for the user, how that's likely going to change in the next few seconds. But there, of course, are significant security question marks here. Like, can you actually share that information without, for instance, accidentally disclosing where the user is? So I think I'll stop here, and I don't know if my co-authors want to add anything, Ted, Mirja, Tommy, but otherwise open it up for discussion.
Okay, you got back in queue, Torlis, but it looks like Adrian's first. Adrian?
Yeah, thanks. Thanks, Jari. That was a really helpful presentation, which clarified a lot of things for me from the draft and made me think a lot. In your slide 4, there were, I guess, two things that struck me. One was that the middle box, not the middle box, but the middle box, the info that is needed for the task, and that's a really dangerous open door. So I think you have to be careful with that, because one person's need is another person's bad idea.
Yep. Absolutely.
That sort of leads on to the consent of parties thing. And we sort of see that with the geolocation stuff, that the application decides is not the same as the user consents. And the user consenting is not necessarily the same as the user understanding what they're doing. So all of that is just a little bit grey and fuzzy when we talk about this. But anyway, please bring these thoughts to the APN BOF first session tomorrow, because that's very pertinent.
Yeah, that's been actually one of the inspirations for some of this work. Like, what can we do and what can we not do? And I fully agree with your points, and in particular the one about things needed for tasks. And the comment that I would make here is, just because I'm a network element and I think I want to do a task doesn't mean that other parties should actually agree to that. So even the existence of a particular task needs to be a thing that you consent on.
Yeah.
Correlate.
Yeah. Okay.
Interesting work. I mean, the very high level, and sorry if this is, sound like a standard rant or disclaimer, it may be, right? But it very much looks like what is certainly very important, but also the most difficult case, which is how to make these things work over the most, difficult scenario, which is the internet. And so it would really be helpful to maybe start creating a list of, different category of scenarios, where on one side you have the, everybody trust everybody else because it's a physically isolated network, and then going from there to the other side, which is the open internet. And there are a lot of fewer problems that you get when you start from the simple side. And if we would put, for example, all these type of requirements here that rightfully apply to the internet upfront against the design of, let's say, packet processing of MPLS or so, we would have never deployed it. And yet we do know that it is important and works perfectly fine in private networks. We've done a lot more security work even for these limited domain networks in the recent past. So for example, the Anima work simply automates what's been very much standard in many of the secure networks I know, which is just hop-by-hop link encryption, secure nodes. So you don't have to put all this security into the end-to-end signaling, right? So there are a lot of different options here, and would be great not to only focus on the ones for the internet, because in my opinion, my counting, 90% of our, IETF protocol business is being made outside of the internet in a humongous number of private and limited domain networks.
Yeah, that's an excellent point, of course, and should say that there's, of course, some differences of opinion to what extent we believe in particular forms of limited domains going forward. So there's some thinking about the future as well that we need to do. Thank you. Jeffrey.
Thanks for the excellent presentation. I think there's an interesting place somewhere between the consent of parties point and the securing the signals point that I'm not quite sure you covered in the presentation, and if so, I may have missed it. Part of the problem for some of these signals is that it's a matter of scoping for some of them. A lot of our protocols are effectively designed, to go end to end, and whether you choose to disclose information that can be used for path signals may vary depending on where you are at a given network. Now, clearly, we do a lot of tunnels for various things, and that may be the answer in question, but maybe that should actually be called out as an explicit point.
Yeah, that's a good point. Thank you. Ted.
Howdy. I wanted to kind of talk a little bit to the points which are being made kind of contemporaneously in chat, because I think there's some confusion about some of what's intended here. Because I think in a lot of cases when we're talking about path signals, what we're talking about are necessarily ones where the action which is taken as a result of the signal isn't a command, it's advisory to some extent. And I think ECN is one we're probably all very familiar with, right? And so this is a signal which comes through the path, and it is advisory to the nodes through which it passes. And the decision exactly what action to take is not set in stone. And I think in a lot of the cases when we're talking about these, what we're actually trying to work out is what are signals that are useful to send across the path that retain that sort of advisory character and that are useful to both ends of the flow as well. And I think the most controversial one is obviously the one that Brian and I talked about some time ago, which is the source quench issue. It's like, obviously the internet had that at one point. It was far too dangerous to use and it got dropped. And what's the advisory version of that, right? And the advisory version of it is a mechanism that lets one side of the flow tell the other side of the flow and the path, and this is the interesting bit, that the flow is being dropped at the other end, that it is not being delivered to the node that it was intended for. And obviously in a well-constructed protocol, the other sending side is going to know that that's happening at some interval, right? There'll be a withdrawal of consent in RTC Web, through the stone ice mechanisms that were designed for that, as an example. And the sender will stop upon receiving that from the other side of the flow. The question is, if you have a bad sender, one who is engaged in attack, is there any advisory mechanism you could send to the path that would say, by the way, this is being dropped. So if you don't want to send it to me, so you don't use, your high BDP satellite link, or you don't want to use your expensive non-peering transit link or whatever, you now know it's not getting to the endpoint, and you can decide whether you want to send it further or try another path or do something else. Now, the critical thing that stopped this work kind of in its tracks is it's incredibly difficult to work out what signal you can send in such a situation that isn't subject to an injection attack. And we played with a whole bunch of different mechanisms that would allow the end system to know that it wasn't an injection attack, and we kind of believe that that's a solvable problem. But letting the path know that it's not an injection attack from some other part of the path is very difficult indeed. And so I think it's an area for research for a darn good reason. There is no engineering work to do right here. But there is research to do to figure out if there is some mechanism that would let those advisory messages demonstrate that they are able to take the action that they're claiming to take. And so there's some interesting research here to do, but it is definitely not done. And that's the reason you don't see a proposal from us in the form of an internet draft, but noodling on the side of napkins in the way that these things go. Thanks.
Thank you, Ted. Yeah, I don't see anybody else in the queue. I haven't read the chat window, but I will do after the session, or at least after finishing here.
Yeah, I don't see anybody else in the queue. And so with that, let me stop sharing here, or maybe I'll switch back and I'll go to the any other. Let me do this and go through here and go to open mic. We have about 7 minutes left. And Mark.
I wanted to react to the characterization of Model T that's a couple slides back from this one. I went back and looked, and the last time that the IAB convened a Model T meeting was exactly a year ago. It was on July 30th, 2020. So in that year, the IAB hasn't convened another meeting, but still the participants in it have revised older drafts, they've created new drafts, and members out of the community have volunteered to help with the organization. So I think what's missing, what I'd like to see, is rather than an IAB review of the program, to put some energy back into having Model T meet. I think that would be a really valuable thing. There are community members who are willing to contribute, and they've proved that in the past, and we just haven't had the IAB convene any meetings. Thanks.
Yes, so that's definitely true. The leads of the program haven't set up a meeting, and the IAB wasn't as much involved and this recently, but this is really also part of the review that we want to take to see what the view of the IAB on this program is, how much interest is there in the IAB, and how do we proceed with this topic, because an IAB program really needs IAB backing. It's not a pure community group. We always have to have some broader interest in the IAB in order to keep it driving, to make sure we have everything organized and in line. So this is really the purpose of the IAB program review. And after the review, we will come back and figure out what to do next. And Yari is there. I'm pretty sure you want to say more about it.
Yeah, yes, I just wanted to agree with the characterization that this is sort of a, I wouldn't say an IAB problem, but it's a leadership problem for the Model T group, and I'm part of the leadership, so I'm at fault here. That's clearly been a problem. We've seen that there's lots of energy, or at least some energy, on producing documents. So let's fix the leadership and do something. Thank you.
All right. I think next is Watson.
Hello. I was just going to say that when it comes to Model T, I think there remained a very big gap amongst participants, and discussions sort of dwindled, and it's not clear there was any progress towards closing that gap. And I think that before we say, oh, another meeting will solve it, another round of drafts will solve it, the discussion on the list has really dwindled. In part, I think there's very little prospect of progress towards addressing those issues. So I would like to see that there's some path forward before we decide, oh, okay, another round of whatever is gonna fix it.
Yari. Yari?
Yeah, I also want to agree with this statement. I think there has been a gap of like, what exactly are we doing? I think some of that was how you characterize things, that there's no progress towards solution. I think there's difference of opinion of exactly what should be produced. I think there's many possible alternatives. I'm kind of like in favor of short, to the point, high-level RFCs from IAB, at least, like 8558, that says a thing and doesn't go into huge amount of detail. I think this might be case for that. I don't think everybody else is on the same plan. And there's been a lot of interest in looking at a lot of the detailed technical solutions that we could do, and but it's also a problematic area, because it's so many dependencies, and it's not as easy thing to tackle, going beyond communication security as some of the let's encrypt this packet type of problems. So part of this is baked in the problem.
So I just want to, before we have a very lengthy discussion here, we didn't have an extensive report on this program because we really have this review coming up. So these are all questions that we need to discuss in the IB, where we are with the program, where we want to go, and what the right direction is. And then we can report back and tell you more what we want to do next there. Two more minutes for some final questions, or we call it a day.
I was just going to say the same thing.
I can show this in case people are still in here. Okay, everybody, have a good rest of your day or good night, and see you tomorrow again, maybe.
Yeah, it came out of there and showed up on the adjacent display. It's like magic. All right, good night, everyone. And Cindy, thank you for taking minutes. And to the MeetEcho team, thank you. I know it's late for everyone in Europe. I believe they're all based, many or all of them are based in Italy. So thank you for supporting us this week. It's been awesome.
Thanks.
It's worked smooth for me.